Okay, so here is another graphic that I wanted to share with you that I think would be really helpful. It's just something else that you can look at in addition to the other factoring flowchart that I've shown you. But now that we know all the methods and now that we know how to do all of the different all the different types of factoring, I kind of wanted to put it together in like one condensed area for you to look at and for you to use when you're going through a practice sheet that involves more than one type of factoring. So far, we've kind of focused on each type of factoring individually, and now we're going to mix it all together. So I think this is really going to help you, and I wanted to walk through this with you, and then walk through the different examples down at the bottom with you, so that way you have examples with the names and you have it all together in one spot. So here we go. So first and foremost, you start at the top and you always want to look for a GCF in the polynomial first. So before you do anything, before you start factoring, before you start moving things around, before you even start brainstorming, I want you to look to see if there's a GCF. I want you to see if there's that greatest common factor in every term in the polynomial. Okay, I don't care how many terms there are. There could be 1, there could be 5, there could be 10. I want you to see if there's a greatest common factor between all of the terms. And if there is, I want you to factor that out right away. Okay? And then depending on whether or not, if there is a GCF, factor it out. And then leave it outside the parentheses, leave a big set of parentheses, and leave the polynomial left on the inside, and ignore everything on the outside of that parentheses. You're not going to touch it again. You're just going to leave it alone. Okay? Then, looking at the polynomial that is, if you did factor out a GCF, looking at that polynomial that's left inside those parentheses, or if you didn't factor out a GCF, looking at the only polynomial you have left for the problem, determine how many terms it is. Okay, so if it's 2 terms, 3 terms versus 4 terms. Now, we did not talk about anything higher than 4 terms, so you won't see anything higher than 4 terms, just like you won't see anything less than 2 terms. Okay, so if it's 2 terms, it's going to be difference of 2 squares. If it's 2 terms and it's not difference of 2 squares, you can't factor it. Okay, there may be a couple of problems that you're given that you can't factor. Okay, and that's something you should be able to identify as well, is can I factor this or isn't it factorable? There's something in Algebra 2 then that you're going to learn about the polynomials that you can't factor. What do you do and how do you solve for them? And it kind of takes you really dive in deep more in Algebra 2. And we even dive in a little bit more later in Algebra 1. But for now, you just need to be able to identify how to factor and whether or not you can factor it or you can't factor it, and then break it down from there. Okay, so it's 2 terms, difference of 2 squares. So that's when you have 1 square subtracted by another square. All right, so an example, what does that look like? Well, first example is x squared minus 64. Well, x squared is a perfect square, and so is 64. Okay, another example. Actually, you know what? Before I get to that, let's go through this example. So here we go. How do we factor this? It's going to be 2 sets of parentheses. You break up your first term into x and x. And then what are the factors of 64? Okay? So you want to break it down. It's a perfect square, meaning something times something gives you 64, and those somethings have to be the same. So 8 times 8 gives you 64. One's going to be minus, one's going to be plus, and that's going to be 8 and 8. Guys, we don't care which one says plus and which one says minus, but this is our final answer. Okay, and remember, the way to always check your work is if you FOIL it out and you multiply these 2 binomials together, you're going to get the x squared minus 64 back. Okay? The reason why I skipped this one, 18 and 2 are not perfect squares, but what do you notice about this polynomial? It has a what? It has a GCF, so we have to factor out the GCF first, and then we can look to identify whether or not it's a difference of 2 squares. So GCF, 18m squared times n minus 2n cubed. So they both have the factor 2, and this one has 1m, but this has 3, so the greatest common factor they have is 1n. So my GCF is going to be 2n. I'm going to factor it out. So when I factor it out, that means I divide. So 18 divided by 2 is 9. m squared times n divided by n means my n's are going to cancel, and I'm left with my m squared. 2 divided by 2 is 1, so minus 1, but then n cubed divided by n. N cubed divided by n is going to be n squared. Okay? Now, 9 is a perfect square, m squared is perfect square, n squared is perfect square. So again, I'm going to leave my 2n outside of my parentheses, leave it alone. Okay, I'm not going to touch it. I'm just going to leave it there. I want to break up my 9 into 2 terms. So I'm going to, here's my first set of parentheses. Here's my second set of parentheses. Break up 9 into 2 equal numbers. 2 numbers that are the same. 3 and 3. They multiply to get 9. Break up m squared into m, make 1 plus, 1 minus. And then break up n squared, which is going to be n and n. And then this is my final answer, and I'm done. Okay? So now let's talk about 3 terms. Okay? So we looked for a GCF. We either found one or we didn't. Okay? And our polynomial that's left has 3 terms. So it's called a trinomial. So we either have a trinomial where it's x squared plus bx plus c, where it's just x squared out front, or a variable squared, right? Or we have it where it's ax squared, meaning we have a number in front of our x squared. So for example, right here we have x squared minus x minus 42. Over here we have 30x squared. So we have that number out in front. All right, so let's start with this guy over here. How do we factor a polynomial, or a trinomial rather, that looks like this? We're going to have our 2 sets of parentheses. We break down x into 2 terms. So x and x. We break down x squared into 2 terms. Okay. This is when we take the factors of negative 42, that add up to negative 1. So factors of 42, so 1 and 42. We've got 2 and 21. I'm going to skip ahead here. We've got 6 and 7. So 6 and 7 is going to be the combo that I need to get my negative 1. One of them has to be positive and one of them has to be negative because I need negative 42. So I need my 7 to be negative, so minus 7, and my 6 to be positive because negative 7 plus 6 gives me negative 1. And then this is going to be my answer. Okay. Now, this guy, I know it has a coefficient out in front here. So you're probably saying, well, that doesn't belong in this category. But what do you notice about 2w squared plus 20w plus 50? It has a GCF. It has a GCF of 2. So I'm going to factor out the GCF of 2, and I'm left with w squared plus 10w plus 25. Okay? Again, I'm going to leave my 2 outside of my parentheses. I need 2 sets of parentheses here. Break down the w into w and w. I need to break down the 25. And it's going to become 5 and 5. So my factors of 25 are 1 and 25 and 5 and 5. So I only really have one option to get that 10. So it's going to be w plus 5 and w plus 5. What do you notice about w plus 5 and w plus 5? They're the same. So we're actually going to write this as 2 times w plus 5 squared. Okay, remember when we talked about perfect square trinomials. All right, so next we want to talk about a trinomial with a coefficient out in front. So this is the method that we've talked about most recently other than factor by grouping, okay? This is when we take that number out in front, we multiply by, so we take the 30, we multiply by 6. Right? I kind of goofed already only because I forgot to look for a GCF. So even I forget sometimes to follow this pattern, but we have to look for a GCF first. So I'm actually going to cross this out. And what do you notice about 30x squared minus 27x plus 6? It has a GCF of what? It has a GCF of 3. So I'm going to actually go ahead and factor out the GCF of 3, and then we're going to get 10x squared minus 9x plus 2. Okay, so ignore that up there for right now because I did forget. I do apologize. I did forget about that GCF. All right, so now we're going to take the 10 and multiply it by the 2, and then we get 20. So I want factors of 20, and I'm looking for that combo to get 9. So 1 and 20, 2 and 10, we've got 4 and 5. 4 and 5 is going to be my combo. I leave the 3 alone, right? It's my GCF. It stays outside. I'm going to leave my 10x squared, and I'm just going to break up that negative 9x. So we've got negative 4x minus 5x plus 2. Okay? Now I am going to do this in another color just because there's a lot of black going on. Again, leave the 3 there. We're going to factor by grouping here in the middle. And again, we are going to go over a factor by grouping example as well. But factor by grouping, so find a GCF of the first set of parentheses. So 10x squared minus 4x. Greatest common factor is going to be 2x. So divide it out. Then we have 5x minus 2. And then negative 5x plus 2. I want whatever GCF I pull out, I'm going to be left with a set of parentheses here. And I want to get 5x minus 2 in this set of parentheses. So I know my GCF has to be negative 1. So then I do get my 5x minus 2, right? 3 stays outside again. And I'm going to factor out my 5x minus 2 from this term and this term. And then I'm left with my 2x minus 1. And then that's my final answer. Okay, so then last but not least, when you have a polynomial with 4 terms, you're going to do factor by grouping, which is going to be this guy over here. I'm going to try and make it so that way you can see as much as possible. So first and foremost, what do we always do? Look for a GCF. 2a cubed minus a squared b plus 10a minus 5b. There's nothing in all of the terms, right? So we're just going to go straight into factor by grouping. Group the first 2 terms together, group the second 2 terms together. Factor out a GCF just from these first 2 terms. So I have 2a cubed minus a squared b. They both have a's, and they actually both have at least 2 a's, so my GCF is going to be a squared. I'm going to be left with 2a minus b. Okay? And then 10a minus 5b, the only thing they have in common is 5. And then we'll be left with 2a minus b. Again, my parentheses should be the same. Then I'm going to factor out my 2a minus b. And I'm going to be left with my a squared plus 5. And I'm done. Okay? Sometimes when you factor by grouping, you're going to get down to this point, and you may end up actually getting a difference of 2 squares in your factor by grouping. It doesn't happen often, but it will happen once in a while, so make sure you keep an eye out for that, okay? So when you do go through each process, just make sure you look at each set of parentheses and you look at all of your results, and you make sure that they're fully simplified as much as possible, and that there's no other pattern involved or no other pattern that you recognize. Okay, so real quick, I do want to look at this practice worksheet with you and use this flow chart and kind of show you how to use it with real life examples. Okay, so let's look at number 4. Okay, so number 4, 4k squared plus 20k minus 96. First and foremost, what am I going to look for? Well, according to my chart, the first thing I'm going to look for is a GCF. So I'm going to look for that GCF. Sorry, it's kind of hard to juggle so many papers. So first and foremost, I'm going to look for my GCF. Okay? Now, in 4k squared plus 20k minus 96, is there a GCF? Yeah, the GCF is actually going to be 4. So I'm going to factor out a 4. So I get 4. Factor it out. I'm left with k squared plus 5k minus 96 divided by 4 is 24. Okay, now I'm going to leave whatever's in my parentheses. I'm going to leave the GCF outside alone, and I'm going to just work with this inside polynomial. And it has 3 terms, which means it's going to be a trinomial. So we're looking at 3 terms, trinomial. All right, so I'm going to go back to my page. Does my k have a coefficient? No. The coefficient is 1, so it's going to fall under this category. So I'm going to follow this method right here, right? So I'm going to look to see factors of the last term that add up to the middle term. So I leave the 4 outside. I get 2 sets of parentheses. I'm looking for factors of 24, so I've got 24, 1 and 24, 2 and 12, 3 and 8. Oh, that can give me 5, right? I want negative 24, which means 1 has to be positive, 1 has to be negative. So positive, negative, okay? I'm going to go ahead and break up the k a while. 1 has to be positive, 1 has to be negative. And I'm using my combo of 8 and 3. I need to get positive 5, so my 8 has to be positive and my 3 has to be negative. And then, guys, I'm done. That's all I have to do. Okay? So I just kind of wanted to go through and show you how to use this flowchart and how I think it could be really beneficial to you. Let me know if you have any questions.